So similar means the same shape, but not necessarily the same size. I didn't draw that very well. So what do we know about the sides on similar triangles? Yeah, they're proportional. They're not equal, they're proportional. So like A over B equals D over C equals E over F. Okay, the ratios of all the sides should be the same. What do we know about the angles in similar triangles? They are congruent, yes. Corresponding angles are congruent, and the corresponding sides are proportional. Yes, that's it. But when it comes to triangles specifically, we also know 3 ways, besides showing all the sides are the same ratio and besides showing all the angles are equal. We know 3 ways to kind of fast forward on the triangles. So, do you guys remember what those were? SAS?
SSS.
There's one more. AA.
Oh.
Okay, so SSS means the 3 sides are in proportion like this. 3 proportional sides. Not 3 congruent sides, 3 proportional sides. Angle just means 2 of the angles are congruent. 2 pairs of angles are congruent. And side angle side is 2 sides are in proportion and the angle in between them is congruent. So, like an example of that would be if this is like 4 and 3 and 8 and 6. That would work. Because does 8 over 4 equal 6 over 3? Yes. Are the angles between them congruent? Yes. So that these 2 triangles would be similar by side angle side. For example. Okay, so number 1, it says Maya needed to determine the longest distance across Grand Lake. She blank in the diagram. Provide an argument. So why do we know that those triangles on the picture on the right are similar?
Oh, because they have the angle,
The vertical angles are the same, yes. So what do we got? Yeah, does 5 over 15 equal 6 over 18? Yeah, they both reduce to 1 to 3. And the angle between them is congruent, so it's by side angle side similarity. We know those are similar triangles. Why did I do 5 with 15 instead of 5 with 18?
Because that wouldn't work.
If they are, it's twisted, but I can tell because if this is the small one up here, if they are similar, it should match the small one up there. Does that make sense? So this bigger one should go with this bigger one. So anyway, yeah, side angle side. We're not gonna do a whole proof. B. What's the distance across Grand Lake? So that would be in the picture. That would be this thing. So how could I set up a proportion to help me solve for x?
6 is to 18.
Okay, 6 over 18.
Or 6 to 15 is like 15 works.
Right. 6 goes with 18, that's 15 goes with x. And then how did we solve these way back in the day?
Cross multiply.
Cross multiply. So 6x equals 15 times 18. Was that 270?
Yeah.
Divided by 6. 45 meters across the lake. Okay, so you can measure the width of something without actually going across the lake with the tape measure, just by using similar triangles. Anyway, number 2, the CHS STEM Club decided to take a field trip to test what they were learning in math class. They decided to find the width of the Colorado River at a particular point A as shown in the image. Pacing from point A, they located D, E, and C as shown in the diagram to determine the width of the river. So we just need the width of the river, which is that blank spot they put in the picture. this one's a little bit trickier. So, if I did 30 on the big triangle, what would that match on the little triangle? 10. 30 over 10 equals, okay, now up here on the top side, I need, if I went big triangle, little triangle, I need to go big triangle to big, little triangle. What's a side on the big triangle up there?
20 plus X.
20 plus X. Why is it not just 20? Because 20 is not the side of the triangle. This is the big triangle. You guys see the two triangles? So we need to go big triangle to little triangle, which is just X. Do you guys know why we know these triangles are similar? Angle, angle. Anyway, and then we cross multiply. So 30x equals 10 times anyway, so 10. Now I can't, it doesn't really look right in the picture, but the picture is not to scale, so you can't really trust the picture. All right, now somebody help me set up number 3. Basically, you can tell what's going on in the picture, but Bella needs to know how tall the tree is. She puts a mirror down. When anything hits a wall, you can expect it to bounce away at the same angle that it hits at. So these two angles will be the same. And of course, they're both, the tree and Bella are both standing at a right angle. So, angle, angle. These two triangles are similar. Somebody help me set up a proportion for this one. Shannon? Yeah, that's it. This one wasn't that. No big tricks on this one. We need to cross multiply. I don't want to cross multiply on all these. I think you guys are probably pretty safe on your algebra part of it. Okay, but number 4. So, we are given that, like, this one over this one equals that one over that one, or whatever. And the question is, why do we know these two triangles are similar? So, AC over EC, I guess actually these two are the matching ones. AC over EC equals BC over CD. And what else do we know in the picture that they didn't tell us? Vertical angles are congruent, so how do I know these two triangles are similar? Side angle side. Now, usually these marks aren't right. That's supposed to mean they're congruent, not that they're the same ratio. But, yeah. These ratios are the same, and this angle between them is the same side angle side. B, you guys see the 3 triangles in the picture on B? Little triangle, medium triangle, big triangle. It says in the given that those lines are parallel, that look parallel. So how do we know those triangles are similar to each other? Well, what do we know about parallel lines? One thing is that corresponding angles, if you have a line crossing, the angles that are corresponding are congruent. So those angles are congruent. These angles are congruent. So why do we know these triangles are similar? Angle, angle. They all have the same 2 angles. They all, yeah. Yeah, anytime you know 2 angles are the same, that implies all 3 angles are the same in a triangle. But yeah, they all share this top angle too. Okay, and then on the bottom bow tie, they give that those LQ and NP are parallel. Well, if these lines are parallel, what do we know?
Sure.
Okay, this angle has to be the same as this angle. They're called alternate interior angles. You guys remember that? Like this angle and this angle. It's the same thing, it just looks different because it's sideways and doesn't have the extra lines. But alternate interior angles are congruent on parallel lines. And the vertical angles are congruent, so it's angle, angle, again. You really only need two angles, you don't really need all three. Okay. Some of these are not similar on 1 through 5. Most of them are. So on number 1, does 60 over 30 equal 50 over 25? Yeah. So we can say those are similar. So Caden, what's a similarity statement we could use for number 1?
30 over.
No. Similarity statement is like triangle blah blah blah. It's,
Oh yeah, I got you. Okay. So it's like triangle TUS is similar to triangle HGS.
Yep. TUS, HGS. The order doesn't matter. But that is one of the orders you could use. And how do we know that's true? Side angle side. We know the sides around the vertical angles are proportional. And the angle in the middle is congruent. Number 2. Grant, do we know those two triangles are similar?
What? What about like how they are similar?
Do we know? Yeah.
Because of angle side wait. I can't tell.
Angle side angle is not one of them.
Oh yeah. Would it be angle for?
Yeah. Angle angle. And what's the similarity statement? Triangle.
KLM is congruent to
Similar to.
To CBA.
Okay, KLM, CBA, that would work. Okay, Eli, number 3, does, let's see. It's kind of random. Does 24 over, I'm not sure where that 30 is hanging out there for some reason. Does 24 over 18 equal 30 over 22?
30 over 22? No.
No. There's lots of problems with that one. Also, even if they were the same ratio, the angle is not between the 18 and the 22. So that one is just not similar. Okay, Forrest on number 40 thinks 6 over 9 equals 6 over 9 equals 9 over 13.5.
No.
It actually does. Half of 9 is 4.5. Yeah. So how can we tell though for sure? Does 6 over 9 equal 6 over 9 equal 9 over 14 or 13.5? If you reduce them all, well, how do you reduce 13.5 though? Doesn't really work very well. You could divide them all.
Oh yeah, that's right.
But yeah, they would all reduce, if you divide them, they're all like 2/3 or 0.6 repeating. If you divided them all. So actually they are. So how do we know the two triangles are similar then?
Side.
Side, 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 and what's a similarity statement we could use?
Triangle FDE similar to triangle VUW.
Yeah, actually you can go both ways. Since it's an isosceles triangle, you could go WV or VW. It would match. Okay, number 5. Willow. Let's see. Does 6 over 3 equal 12 over 6? Well, let me pause there. Does 6 over 3 equal 12 over 6? Well, how are 6 and 3 related to each other? Twice big. So yeah, that does work. And does that equal, all we got left is 11 and 5?
No.
Yeah, that one doesn't, these would reduce to like 2 to 1. This is like 2.2 to 1. So it doesn't, so 5 is just not similar. Shelby, how could we, so down in the middle, bottom of your page, we got a couple triangles left. You're supposed to solve for x. How could we set up, Shelby, the bottom left one to solve for x?
2 over 5 equals 4 over 4 plus x.
That is true, but it actually also works to do, so she did 2 over the big triangle, 5 equals 4 over 4 plus x. When the picture's like that, the lines are going to be parallel. You can actually even do 2 over 3 equals 4 over x in this case, when you have parallel lines like that. Even though 3 and x are not sides of the big triangle, the parallel lines kind of makes it work anyway, so it's a little easier that way. Anya, how can we set up the bottom right? A couple ways we could do it.
Would we do 30, or would we do 40 because it's the entire triangle?
Well, it doesn't
30
matter.
plus x, so you don't have the, or we do 12? 30 plus 12.
Well, not plus. So we need something over something. So if you did like 30 to start with, what would, there's kind of a couple ways you go after that. 30 could go with what?
12, so it's the same on either side.
Well, 30 on the left triangle, on the left side of the little triangle, you could match it with x on the right triangle, or you could match it with 40 on the big triangle. So you could go like little left, big left, Shannon. Yeah. Okay, so you got, there's actually a lot of options we could do.
Are you using both of the triangles, or just the one?
Both. You have to have two triangles to have a similar relationship, the equal ratios.
30 over 2.
30 over 10? Yeah.
2,
Is that what you said?
10.
Okay. So yeah, we could figure out that if this is 40, this is 10. So you could do 30 over 10 equals x over 12. That would work. You could do 30 over 40 equals x over x plus 12. That would be more work, but it would work. You could do like 30 over x equals 10 over 12. There's a lot of ways you could do it. Okay, this third page, these top three I'm a little bit concerned about. They're just hard to remember. I don't know, I'm kind of doubting you guys remember it right now. I actually want to start on the top right though. How could we find those things? Do these problems ring a bell for you guys? Probably not, maybe a little bit. Okay, when you have an altitude drawn down from the right angle, x, the altitude is going to be, they call it the geometric mean of these two segments, or basically you just square root 84 times 16. Not hard to do, kind of hard to remember though. And usually, you know, we like simplify this stuff, right? Whoops, 4 and 21. Most of you probably have a calculator that can do that, but it's 2 and 4 come out, so it's 8, and then 3 and 7 stay behind. 8 squared, 21. Okay, but on the middle one, the top middle one, what's different? They're asking for a leg on the big triangle instead of the altitude. You guys remember how that one worked? You just use the close segment, 45, and the entire thing, 81. Use a close segment, 45, and on the whole thing, 81. This is going to simplify because 3 times 9. And the top left is actually the hard one because the x is, the variable is on the hypotenuse this time. It's part of the thing. So this leg right here should equal the geometric mean of the close segment and the whole thing. So in other words, 60 should equal the square root of 36 times 36 plus x.
Is this specific one on the top?
I probably didn't put that third one on there, but it's a pretty good chance I put one of the other two on there. Or a lot of times when we did this problem, it would look something like this. Remember doing that? So like B would be square root of 6 times 10, A would be square root of 6 times 16, and C would be the square root of 10 times 16.
Is that gonna be on the top?
It's the same thing. I'm just writing it in the this is you. I'm saying this is how we probably saw it the most, written the most like that. But it's just kind of combining the first two problems we did. Okay. Yeah, there's a good chance I put that on there. I don't really remember because I didn't make this test this year, but there is a good chance. Okay, this one right here with the, it's actually a little bit trickier than it looks, I think, because well, if those lines are parallel, what do I know? Alternate, yeah, the alternate interior angles are congruent. So that means that if this angle goes with this angle, then this side goes with this side, and vice versa. So it's a twisted bow tie. We've had a couple of those already, but in other words, the 2x minus 2 should go with the 15, not the 20. So it's, you could do, you could do 2x minus 2 over 15 equals x plus 9 over 20. That's one way you can do it. You guys get it? It's a twisted bow tie, so you gotta kind of go crossways. There are other ways you could set it up. You could do this over this equals that over that. Just everything's kind of backwards. Issa, how could we, this bottom right one that we haven't done yet, how could we set that one up?
Well, you see.
Just take a guess. It's not a trick question.
No.
20 could go with what? 28 equals what?
3x plus 7 over 16.
cross multiply from there. Okay, Olivia, you don't really have to read the story problem because it's kind of all in the picture. They're basically asking how can we find the height of that building. Now, when it comes to shadows, the sun is going to hit the flag and the building at the same angle. So that means like this angle is the same on both triangles. So anyway, they're similar shapes. So Olivia, why don't you try setting that one up? As long as you follow the pattern, you should be okay. Just follow a pattern. There's more than one pattern. So choose a number, choose any random thing.
60.
Okay, 60, what could that go with? 60 on the little triangle matches what on the big triangle? 170. Okay, equals, keep going. Yeah, I'll do it. Now, I should, and then you cross multiply stuff. I should point out though, sometimes instead of giving you the 170 as the whole thing, they might give you like 110 just right here. And if they did that, you could get it wrong by just saying 60 over 110 does not equal 35 over h. Because 110 is not a side on the big triangle. And sometimes they don't, so sometimes they don't tell you, like the whole thing right here is 170. Does that make sense? So if you go side on the little triangle, you need to do the matching side on the big triangle, which is not 110, because that only goes from there to there. You would need 170, the side on the big triangle. Okay, now if we were looking, I know this is confusing, but if we were looking for, let's say, this, you could do 60 over 110 equals 70 over 1. That actually does work. But only on the parallel stuff. It doesn't work for H. It's kind of confusing, I guess. Okay, why don't you guys try and draw a picture for that bottom one and see if you can set it up. We're almost done.
Is this gonna be the last one we go over?
No. Girls. It's pretty much the exact same problem as the last time. Tower, pole, shadows. So you could do x over 5 or x over 54 or whatever. X over 5 would equal 54 over 7. That's one way you could write it. Or there's a bunch of different ways. But when you cross multiply though, you should, no matter how you set it up, when you cross multiply, it should look something like this. 7 times x equals 5 times 54. Okay, I just want to do the top 3 on the back page. The other thing's like a weird dilation thing, but we don't have to worry about that. We did a much simpler version. So those are not trick questions, but let's go ahead and set them up at least, even if we don't solve them. Shannon, how about the top left one? a bunch of different ways you could do it. 8/6 equals 2x minus 10 over 3. That's one of the ways you can do it. Or you could do, I always think of it like 6/3 equals 8/2x minus 10. Because it's kind of already looks like that. But either way, it's all good. That works. Okay, Kate, now about the second one.
It's like, negative 5 plus 2x over 9 equals 40/24.
Yeah. So basically, they're saying when you draw on an angle bisector, those ratios are going to be equal. Huh? Probably not. I don't think I put one on me. But I'll try to be nice when I grade. How about that? Give you as many points as I can.
Wait.
It's not working. Okay, and Grant, how about the right one? It's back to parallel lines again, but
It'd be like 8/12. Wait, no, 8/.
you could do 8/12, but go ahead.
Okay, 8/2x minus 2 equals 12/27.
Yes, that would work. Alright, are we good on that? So, I'm a little bit afraid of these top three on the third page. I kind of feel like you guys will mostly be okay on the rest of it.
Yeah.
Can we see the video now?
Yeah, oh
Yeah.
yeah. Yeah.
When's the last time you saw it?
We never saw it.